So here is a MathCAD worksheet into which I have placed number of parts, number of operators, and number of repeat measurements. I have placed an error sum of squares, an operator sum of squares, and a part by operator interaction sum of squares. And out of this has come mean squares and some other things. Okay, so there is a square root of a mean square for error. Okay, that turns out to be my estimate of repeatability, standard deviation. A sigma hat reproducibility, so there's sigma hat repro, I've called it, and a sigma hat R&R. In addition to those estimates, I've also computed the Satterthwaite approximate degrees of freedom for reproducibility and R&R, and in keeping with the practice that I've started with you in these Satterthwaite calculations, I would take the first and round down to 4, and I would take the second and round down to 7. And for degrees of freedom for quote-unquote error, well, that's going to be this I times j times m minus 1. I is 4, j is 3, m minus 1 is 2, so that without much hassle is 12. Alright, so then you can take these things and check, do the calculations here. For example, say sigma hat repeatability, that turns out to be 0.0054. Units there are inches, and we get 95% confidence limits that are 0.0039 and 0.0089. So that is an estimate of the standard deviation that one operator would see repeatedly measuring the same part. So that's the first kind of thing that comes out of these calculations. Sigma hat reproducibility. Well, sigma hat reproducibility turns out to be 0.0090. So it looks like it's on the order of twice as large as the repeatability standard deviation, and its limits run between 0.0054 inch and 0.0259 inches. And finally, if one takes the formulas for R and R, one gets an estimate that is 0.011 inch, okay, for this combination of repeatability and reproducibility, and with corresponding %95 confidence limits that run from 0.0073 inches to 0.0224 inches. And those are quantifications then of how much variability in measurement can be charged to differences between operators. That's sigma reproducibility. How much is sort of inherent to the way that every operator uses the equipment to measure individual parts. That's sigma reproducibility. And then the combination of those two things, sigma R and R, 0.001. What do we see from these confidence limits? Well, it's sort of, there's a lot of uncertainty here because sample sizes are small. There's only 3 operators involved. So one doesn't have a huge amount of precision for knowing what sigma reproducibility is. Similarly, the sample sizes are small, so confidence intervals are wide, but there's at least some indication that repeatability and reproducibility are sort of roughly of the same order of magnitude. It looks like reproducibility might be bigger than repeatability. Practical upshot of that would be that looks like operators need to be trained, these students who did this measuring, they need to be trained to use the calipers in the same way. I purposely don't really give very good instructions in these in-class data collection labs, mostly so that people can see what it means to have reproducibility variation. But my point here is that if I think sigma reproducibility is big, I need to do worker training and standardization. That is, operators need to know how to do things alike. If I think that sigma repeatability is big, then some fundamental changes or improvements in equipment or protocol are needed. That is, that would say I have some inherent level of uncertainty in measurement that is just unacceptable and has to be addressed across the board.